All right, so section 9.3 is on similar right triangles. So I kind of debated on should we do this section in chapter 8, but left it here for now. But so because it is kind of a isolated case. So if we had a right triangle here, but then we also have, that's not very good, a right triangle it's a little better, like there, and then because it's a line, it would be a right triangle on that side also. So there's 3 triangles in this picture, and they are all similar. So there's a theorem that says, like, if you have a right triangle and then this BD line, it's an altitude, because anything that's a right angle measures height. And so anything that's a height we can call an altitude. But if it's an altitude, so basically if it makes another 90-degree angle there, then we have these 3 triangles and they're all similar. So we have the big one, A, B, C. We have kind of and I'll draw it like how they look in the picture. So we have B, C, and D. And then we have the little one, which is A, and then D, and B. So the trick, if you will, and I kind of like to label, so we have the hypotenuse across from the right angle, so then we have a hypotenuse here, and we have a hypotenuse here. And then we have S for the shortest side, and S for the shortest side, and S for the shortest side, and then I'll do L for the longest side. Or not the longest side, but the longest leg. The longest side of all of them is always the hypotenuse. So the H is always so if you know the length of the hypotenuse is 12, if whatever, then the other 2 sides have to be smaller than 12. Okay, but the point here is if you look at it, you're going to see the same side in different shapes, and it's going to be a different part of the triangle. So for instance, if you look at AB, in the first one, it's the shortest side of that triangle. If you look at AB down here on the bottom, it's the hypotenuse of the small triangle. So it's actually the longest side, but it's the hypotenuse. So you're going to get those different things. So if you look here on the top one again, BC is the longest leg, but then in the second one, BC is the hypotenuse. DB down here on the very bottom is the green, the longest leg, but DB in the one up above it is the shortest one. So that you're going to get these kind of crossover sides. So it's kind of, you got to keep things straight. So if you were going to say triangle ABC is similar to the bottom one or to the next one, right below it, here's kind of what I do. I say, well, the hypotenuse has to go with the hypotenuse. So the H's have to go together, the L's have to go together, the S's have to go together. So I always look at the hypotenuse, just kind of what I do. So AC, is the hypotenuse. So over here, the hypotenuse I would have to do BC like that. And then that means the A has to go in the middle. So if you look, like I go, or not the A, sorry, the D. BC and then D. So if you look, like it goes A, B, and that's down the shortest side. You know, so then if you look on this one, BD is the shortest like side, and then it goes to the C. So if I said ABC is similar to the bottom one, so again, AC is the hypotenuse, so the hypotenuse here is AB. So I'd have A at the beginning and B at the end, and then that means the D goes in the middle. But again, you could also do it like this. AB is, the first two letters that I did. AB is the short side, so on this one, AD is the short side. And then you have to go to the B. Okay, and then so that big one is similar to the other two, but also the bottom two are similar. So if I did triangle BDC, okay, so again I went down the short side, so over here it's going to be A, D, B again. Okay, so all three are similar, which means we set up proportions. Okay, we just kind of did a whole bunch of that in chapter 8. So the first couple problems, the first two, you are going to just essentially list out what I just did. That's weird. Why isn't it drawing? All right, so sorry if the video got weird there for a minute. My pen ran out of battery, so I had to pause the video and charge it. But so the first couple questions, it's just going to want you to write which triangles are similar to which. So kind of write like how I just boxed. I would redraw them out and then go through kind of how we did. Excuse me. Okay. Then we'll get into the different. It's important that you can kind of say, okay, there's 3 triangles and they're all similar to each other, and break them apart. You just write out the triangles that are similar. Solving for x's, and so there's some different formats, I guess, I don't know, to try so if we had, this is like 13 goes all the way to the edge. Okay, so if we add, let's see, B, C, and D right there. Okay, and then we're going to find that side right there. Okay, so you basically need to pick, you're going to work with 2 of the triangles, and it doesn't matter which 2 because they're all similar to each other. But we need to look at, for sure, okay, this X is in either the big triangle of I always say like the whole triangle, and then I say the big and the little. So it's in this triangle that's on the left that goes from like D, B, C. So it's in that triangle, and then I do know that side is 12. It's the hypotenuse because we have a right angle like over there also. So I could use that one. And so if I did that, I would say, okay, I have X and I have 12. And then, so in this triangle, the smaller one, that side, the X, is the short leg. It's the short one. So then if I use, let's say, the great big triangle, the short one is 5. And then the whole thing, the hypotenuse rather, is 13. So, it's this, the visuals of everything. So maybe I should, if I take it out. And so I used the 5 and the 13. And then in that little one, we were trying to solve for that. Or actually, I take that back. I didn't use the little one. We could have used the little one. But we used the one that goes like that. So we're trying to figure out that one. And then I know that's 12. And I actually don't know this side. 13 goes all the way, but I don't know that side. But since I knew the hypotenuse, and in the big one I knew the hypotenuse, so it's okay. And like the other chapter, I said, well, you can, reverse the 5 and the 12 if that helps. And honestly, it doesn't. If I put the 12 on top and the 5 on the bottom, or the 13 in the x, nothing happens. So we'll just multiply the diagonals. Okay, and then divide. And on these questions, almost all of them end up a decimal. It's really difficult to get the numbers to work in such a way that you get whole numbers. So it's going to say, it does say solve for x, and then the answers that the book does, it's all rounded to the nearest tenth. So this is 4.6. Okay, so that's one version of just what information they tend to give you. So, excuse me, there's actually 4 of them like that, where they give you the whole, hypotenuse, of the whole triangle, where they give you all 3 sides of that triangle, and then they ask you to find this other side that's in the middle. Okay, so you'll have 4 of them where, again, the whole side, and then you're asked to find the altitude. You don't need to necessarily remember that word, but I kind of, some of you can visualize it. Some of you, it might be better to write out the 2 triangles that you're going to work with. It just all is, a personal preference on what you want to do. But you need to, I need to see the proportion. I need to see the solving. Just to kind of illustrate something. So let's say you wanted to work with the small triangles. So you said, well, here's x and 5 is the hypotenuse. So if you said x over 5 instead of x over 12, like you did this little one. So the little triangle would look, like that. So if you notice, on both triangles, I use the hypotenuse. Okay, and so then if you went back to, but now, here's the difference. In this little triangle, the x is the longer side of that triangle. This over here is the smaller side. So now, if I go back to the big triangle, if I use the long side, that goes, the x is the long side, and then what's the long side of that triangle? It's a 12, and the hypotenuse is the 13. And so look what happened. It's just the 12 and the 5 got reversed. So there's more than one way to look at it, but you're going to end up with the same numbers. Okay? All right. Okay. The next 4 problems are all going to be like this one, where they give you all 3 sides of the great big triangle, and then they want you to figure out that altitude, or the side that's kind of in the middle of the big triangle. Okay, and then another version of the problem, in terms of just what information they're going to give you. Goodness, that's not a good drawing right there. It's a little bit better, but they'll both be right angles there. Is they might say like, that's 10, that's 4, and let's figure out that one. Okay, so if you look at the whole triangle, I don't know what this side on the left is. I don't know what that one is, and I don't know what that one is. So you need to know or have information about two sides of the triangle in order to use that triangle. So I can't use the big one on this one. I have to use this one that I said, and the picture's not perfect, but I have to use that one that I said was 4 and that one that's 10, even though, you know what, that's going to bug me. That's not even close to being a good picture. I have to use that one, and then I have to use the one that goes like this, and that's 10, and that's X. Okay, so here's like kind of the difficulty, I don't know, like on the one on the right, the X is the long side, but on this one, the 10 is the long side. And then if you go to the 10 on the bottom one, the 10 is the short side, and the 4 is the short side. So, there's two 10s. The 10 on the one triangle on the top is the long side, but then the 10 is the short side on the other one. So it just kind of, you're going to end up with the 10 twice, and that's okay. So if I use X and then the 10 that's in the same shape, okay, like these two, then I need to correspond them. So the X is the long, the 10 is the long, and then the 4 is the short. Okay, and so we get 4x equals 100. And on this one, I got lucky because I literally just made up the numbers. It does equal 25. And we get a whole number versus a decimal. Okay, so there'll be some where they're going to give you, they won't give you like two of the sides on the big triangle, so you're going to have to use the two little triangles. And the last 8 are different versions of this problem where they give you kind of the hypotenuse of the big one, and then they give you some information about that line in the middle, and then they want you to figure out from there. So there's different versions, but and then there's other ones where I'm trying to draw the pictures to look different because you'll see different pictures. But where are they going to want you to find that part in the middle? And then maybe they say that that's 6 and that's 12. So again, if you look at the big triangle, I don't know that side, I don't know that side. So then the two triangles that you're going to use are going to be the two triangles that are kind of made in the middle. And the same thing like happens where, the 6 over here is the short side, but on the other triangle, this X is the short side. And then on this one, the 12 is the long side, and on this one, the X is the long side. So there's two X's there, but on one triangle it's the long side and one it's the short side. So if I start with the one on the left, the X and the 6 are in the same triangle. And then the X is the long side, so the 12 has to go across from the X. And then the two red, like short ones, the 6 has to go across from the X. And what happens is X squared, X times X is X squared. And then 12 times 6 is 72. So to solve that, we have to do the square root of both sides. And then now I need to simplify the square root. So this goes back to some algebra stuff. So what times what is 72? Well, the one that comes to my mind first is 8 times 9. But then I need to keep breaking down the numbers. So I kind of like cross out like until you can't break them down anymore. And then the 9 would be 3 and 3. Okay, I cross out the 9. And then square roots are pairs of numbers. So what I notice is I have a pair of 2's and I have a pair of 3's. So I'm going to do 2 times 3 is 6. So even though it's a pair, I just write one of them. Because really what this is saying is, well, that's the square root of 4, which is 2. And this is saying square root of, 3 times 3 is 9. And the square root of 9 is 3. And then we have this 2 right here left over. And so anything that's left over, we put back inside the square root. And if there was more than one, like if there was a 2 and a 5 left over, 2 times 5 is 10, so 10 would be in the square root. Okay. So there's different versions of, which numbers they give you and which sides they want you to figure out. But again, going back to the first, like I said, you're just going to do 8, 12, 13, 14 problems. The first two, you're just going to write it out like the first one. All of them, write a proportion. Break apart the triangles and write the two that you're going to use. Okay? All right. There you go. Hopefully that wasn't too bad. I had to pause right there in the middle, like I said, but should be all good. Okay? Have a great day, guys. See you tomorrow.